This is Unit 2, Module 11, Ecological Tolerance. Our learning goals for this module are explain what determines where an individual and a species can live, determine how environmental change affects species, and explain how environmental change can cause species extinction. So, for our first one, explain what determines where individuals and species can live. The type of environment where an individual performs particularly well is their range of ecological tolerance. We'll go over what that looks like in just a second. This is also known as their fundamental niche or niche. There's a debate about how you pronounce that. Either way is fine with me. Or where the species can survive, grow, and reproduce successfully. These ranges can be measured by several abiotic factors. So this is what we call a bell curve. Means there's the majority of the population is going to be right here, or the majority of our values will be right here, and we will have some values that are less than and some values that are greater than. But for us, there is a nice little spot here where temperature and performance are at its peak. So here is where a species will grow and reproduce, where they're most comfortable or they can tolerate the most. As you go, higher temperatures, these species can survive and grow, but they're probably not going to be able to reproduce because the conditions won't be right. And then again, further we go survive. And if we go the other way, it might be too cold for these species to need to be able to reproduce. Like plants, they will not reproduce in the wintertime unless they are set up to do that. So they will just survive and grow, but they won't reproduce. And then finally, we have here will they will survive. So every organism is looking to be right here in the middle where all of their abiotic needs are met. Though species can have a range they may survive and thrive in, some biotic and abiotic factors can limit that range. This is known as the realized niche or niche. This can occur through competition, even if abiotic factors for species are ideal. Other species may occupy an area, limiting the first species will be found. So this is an example of what that looks like. So the fundamental niche of these red-winged blackbirds, uh, in this particular field or area, they have everything they need abiotically, and so they have water, trees to be in, there's sticks to build their nests, that sort of thing. The temperature is right, the seasons are good, the wind is good. But then what happens is these yellow-headed blackbirds come in, and maybe they are the predator to these birds, or they'll destroy their nest or something like that. So now these red-winged birds can no longer occupy this space. The way I like to think about that is like your house is nice and warm, and you probably have food crumbs everywhere, and so it is a great place for a mouse to set up shop. But and the biotic factor that would be limiting that is if you have a dog or a cat, right? So they're going to be more likely to make sure that that mouse does not occupy your house because just natural enemies, right? So that would be something that I would say are realized niches. Okay, so now we're on to the second one. Describe how environmental change affects species. Habitats have changed over time, and species have been forced to adapt to these different environments. Change in pollen records have shown that the changes in climate have changed ranges of tree types over time, and looking at the past distributions might be be able to predict future changes. So habitats have changed over time. Species have been forced to adapt to these different environments. So as the world is changing, the species either has to adapt to be able to live there or move on. So one thing that's pretty interesting right now, it's going to be Fat Bear Week in one of the national parks in the United States. And one of the issues that bears are facing right now is global warming is affecting what time these bears are coming out of hibernation because it's reaching early high temperatures too soon. So they're waking up too early and it's not quite spring yet. So they're coming up and they're starving because there is nothing to eat, right? So either these bears have to be able to find different food that is going to be available when they're waking up earlier or move to where it's cold longer, which might result in they have to be able to eat more food in a less amount of time because probably they're going to move north where the seasons are a little bit shorter for the growing period. Changes in pollen records have shown that changes in climate have changed ranges over tree types over time. So what's pretty interesting is in your book it talks about how the tree pollen will get trapped in the water and then will drop down to the bottom of lakes and the oceans and the sediment. And scientists are able to go down there and collect that sediment. And depending on what or how deep they are, they can look through the sediment and find tree pollen and figure out that the trees have changed over time. They also get captured in the ice caps, which we'll look at in just a second. And then looking at past distributions might be able to predict future changes. So looking at this graph right here, we have three different species of tree: pine, spruce, and birch. And then across our x-axis is time and years ago. So this is a present day all the way back to 18,000 years ago. Gray is no data, white is there's lesser abundance, and green is greater abundance. So you can see 18,000 years ago, everything is kind of avoiding the ice cap, and there's only one real species up here of the birch. There's a big population of spruce down here, and then the pine is a little bit more towards the southern region of the United States. As that ice cap is melting, you can see it's going away. Our plants are moving further northwest, and down to the southern tips of Florida, which is pretty interesting. So the change in environment has caused the distribution of trees to change. They can claim more area because the conditions are more ideal for them to grow. Okay, on to our third point. Explain how environmental change can cause species extinctions. So, knowing a species' ecological tolerance combined with the fact that environmental changes cause species to move can identify which species are vulnerable to extinction. So, one species that we have brought back in my lifetime to be not endangered anymore would be the panda. So, their ecological tolerances, they can survive a big range of temperatures, but they really need to live in areas where bamboo grows. So whenever I was in middle school and high school, there was a big push to make sure that we saved bamboo and didn't use bamboo products. That way, there's more for the pandas. Turns out there's other issues with the pandas, like they don't know how to mate in the wild anymore, so we had to reteach them how to do that. But point is if we know an ecological tolerance of, let's say, some rare tree that lives in the northwest United States, we need to be able to figure out if the changes are going to affect that species to save it, because who knows what we could use that tree for, whether it's water purification, air purification. It's a great source of lumber. There's some sort of sap that comes from it that we can use for pharmaceuticals, that sort of thing. There have been five major extinctions in the Earth's geological history. The greatest mass extinction on record took place 251 million years ago, where roughly 90% of the marine species and 70% of the land vertebrates went extinct. Um, it it took place at the end of the Cretaceous period, is when it finally finished, and roughly half of the species, including dinosaurs, went extinct. Which is pretty crazy to think that 99% of species that have ever lived on Earth are now extinct. So, in our last unit, we talked about how many species we think that there are on Earth, and it was about 2 million, is what we believe, but the range is very big, and we still think that that's only 1% of the species that have ever lived on Earth. That's pretty crazy. So there's several reasons why a species might go extinct. The current environment may no longer be favorable. So again, one of the things I'm just going to keep coming back to, because you guys will know what I'm talking about, is global warming. Things are just getting too hot for our organisms to survive, or that's equating to less rain in certain areas, which means the soil is drying out. And then you might have a heavy period of rain where the soil is too saturated and things run off, like nutrients and nitrogen and phosphorus, and so those plants can't grow in their environment anymore. Newly favorable environments may already be occupied by competing species. So you build a house, the field mice are in the field. You have to tear down parts of the field to build that house. You have the house built. It says, oh, that's a nice house for the wintertime, nice, warm, dry place I can stay. Oh, wait, I get there, there's a cat or a dog that is going to outcompete me. So I can't live there. So I have to go find somewhere else to live. That's a good example of that. As well as new favorable environments may have predators that would prevent the successful move. So that would obviously be more of that example than the latter. But you get the point. Their species are already there, going to outcompete it because they're already going to be more well adapted to that area. So back to the 5 global mass extinctions. So this is when a large number of species went extinct in a relatively short amount of time. These extinctions typically happen with major changes in the environment, so climate, meteor strikes, etc. So this is our number of genera, so genus. Okay, we don't measure by species when we look at this because it would be impossible to know how many species went extinct. So we estimate by genus. So, like for example, a lion is a panther leo, um, and so it would be the panther would be the genus, right? And this is millions of years ago, as we can see. There's a steady incline and then a big drop. It was over in probably about 1500, 1600, and then it dropped below 1000. And as we go up, it goes up again, almost reaches 2000, and boom, crashes again. And then the most recent one was up near 3000 species and then crashed below 2. So we would call those mass extinctions. It's when a lot of species go extinct in a short amount of time. So, speaking of that, there was 5. We were working on number 6. Current evidence indicates the Earth is undergoing a 6th mass extinction. That's no bueno. In the last few decades, data showed a reduction in number of species similar to the previous 5 extinctions. The difference in this mass extinction is the cause of rather being caused by climate change or external factors is due to humans. Okay, bad, but we're still trying to figure out how to operate sustainably. Unfortunately, there's not real data on how many species are going extinct, just because it's hard to find all these species. We don't even know how many species are out there, let alone how many are going to extinct. But we think that they have an estimated extinction rate of 24 species a day, is what the United Nations is saying. Um, but the United Nations Convention on Biological Diversity estimates the extinction rate at 150 species per day. We know for sure that there has been at least 800 confirmed extinctions during the past 400 years, which represents about 2 species per year. Um, but these don't confirm any species that may have not been discovered yet. So who knows what the true extinction rate has been. That is your module 11. If you have any questions, please let me know.